today we're going to start by going over what we finished with last time and then move forward from there. Okay, so we're looking at multivariate calculus. Okay, so we're looking at and one of the first things that we have to tune our attention to is that when you're looking at a multivariate function, you're looking at a function with more than one piece. And so you have a function that looks like f of xy is equals to, say, 3x squared minus 2xy plus y squared. Okay? And so that function right here is made up of several pieces as opposed to just having one variable x. So the thing, however, is that x and y are both independent variables, so we have to throw out the y prime. Remember we used to use y prime, find the derivative right here? We cannot use y prime in this setup right here because both x and y are independent variables. Let's try a different one right here. And the way these things work, for instance, if I have to find f of negative 1, comma 2, this means that everywhere I see x, I plug in negative 1, and everywhere I see y, I plug in 2. And then I evaluate the function. So this is 3 times negative 1 squared minus 2 times negative 1 times 2 plus 2 squared. So far, so good? And so this becomes 3 plus 4 plus 4, and so that is 11.
Oh, that's just.
Questions there while I wait on you, time, please? Yeah, you just plug the numbers in, evaluate. Of course, you have to follow your orders of operations. So you have to raise negative 1 squared first before you multiply by 3. So it's not 3 times negative 1 squared. It's negative 1 squared and then times 3. Yes? You know, sometimes I think it would be helpful if I wrote it this way, negative 1 squared times 3. I think that might actually be a little more helpful. Because a lot of people just like reading like they do English, and so they go 3 times negative 1 squared. But I don't know. I know. But for some reason, when you get on a test and you start getting nervous, you'll start doing crazy stuff. You'll start doing crazy stuff. So, we have to introduce new terminology. If I write this right here, f of little x, like so right here, this means the first derivative D-I-V-E of f of xy. I can't spell of anymore, it's not my fault, people. Of f of xy with respect to x. And along with that comes an underlying connotation. The y is held constant. So when we're taking the derivative with respect to x, y's are said to be constant, are held constant. And in fact, when we're doing the opposite, when you're taking the derivative with respect to y, then the x's are held as constants. Yes? Yes? And so for an example, if I have f of xy is equals to 3x y x squared y cubed minus 6 times x to the 4th power y squared plus 8 times x to the 5th power y to the 4th power right here. So, do you see fancy? Fancy. Yes.
I understand you're trying to do, why can't you just keep it simple?
This is simple. All I have is single powers. And as you'll see in a second, life will stay simple. As you'll see in a second. So with this right here, if I want to take the derivative with respect to x, so I can find f of x right here, f of x comma xy right here. What happens is you simply ignore the y's for now. And so right here, what's the derivative of 3x squared?
6.
6x. And so this is simply going to be 6xy cubed. See what I did right here? I held y as a constant, and because y is a constant, you just multiply by a constant at the end. Same thing right here. What's the derivative of 6x to the 4th power? Minus 24x cubed, and then you bring down the y squared. And then the last one over here, the derivative right here, what's the derivative of 8x to the 4th? You're speeding me up, huh? 8x to the 4th power, y to the 4th power. And that, my friends, is the derivative.
And if it was with respect to the y, we would bring down the x.
Right, so if I'm starting the same question again, and I want to find the derivative with respect to y, so it means that I'm holding the x's constant, right? And I'm taking the derivatives of the y's, yes? And so right here, I imagine that there is no x, and so I go 3 times 3 is, and so I'll have 9x squared y squared. I drop 1 power on the y, as I always would do. Yes? Go ahead and see if you can find the other two. Derivatives with respect to y.
Wait, so we're multiplying the number by the exponent in the y?
Yes, this time around. Yes, because it's with respect to y. Yes. You said wait.
Confused.
Yeah, because with the x, the y didn't change, but the x changed.
My x did not change. Originally it was x squared. It's still x squared.
Oh, but it has a 3 in front of it. The 3 stays.
The 3 got multiplied by that 3 right here. Make it a 9.
Okay.
Yes.
So when does the y become 0?
Okay. I see. I was avoiding that because that's actually the exception, not the rule. So I'm going to handle that in a
Oh,
second.
yeah, when we talked
Yes.
about yesterday.
Yes. Huh? Oh, the answer? I know the answer to that. I can go with the answer to that. I don't know. I think I can work with that. Hold on. Okay, so the answer is going to be, the rest of the system is going to be 2 times 6's. So that's minus 12 x to the 4th power y. And then 4 times 8 is 32 x to the 5 y cubed. Questions there? Questions there? Huh? It doesn't get harder than that. It actually gets simpler than that. It's just that it gets simpler than that. It's just that the way I explained last night, I thought about it, and I realized there's a much easier way to explain it. So yeah, it doesn't get harder than this. So let's try again for a different example. So let's say I have f of xy is equals to 2x cubed y cubed minus 3x y squared plus 5, x plus 2y minus 8. And I want to take the derivative of this function right here. Yes? Okay. Same function right here. So, which one you want to do first, fx or fy? Fx. Okay, fine. I'll do fx first. So I'm taking the derivative. What do? I cover the y, correct? Because I don't want to worry about the y. The y is a constant. So I cover the y. What's the derivative right here? So this right here is 6x squared, and then I bring the y down, y cubed. Yes? Then the next derivative right here, what's the derivative of 3x? 3. Negative 3, and so it's going to be negative 3, and then bring down the y squared. So far, so good? So far, so good? Okay. What's the derivative of 5x? 5, right? 5. Now, for the 2y, I'm going to cover up the y. What's the derivative of 2? 0. What's anything multiplied by 0? 0. So the answer is still 0. And what's the derivative of negative 8? 0. So it means that the last two terms right here, both of them don't have an x. Both of them drop off. And that's right here is your derivative. Questions? Questions? A little bit better than last night, because last night you were looking at me funny. Hey, go ahead and try this one for me. Find Fy. Xy. A little bit better?
Yeah.
Alright. Yeah, because the last time you were looking at me funny. Mr. Millsap! Good morning, good morning, good morning. It's the letter of the day. Clap, clap. It's the letter of the day. Clap, clap. It's the, stuck in my head.
What?
Your son loves you. You're such a kid.
Yeah, he was watching Sesame Street this morning. It's not my fault. Okay, so I am taking the derivative with respect to y. So what's it being held constant? The x's. So right here, I cover the x right here. 3 times 6 is 18. I bring the x squared down, and that leaves me for y squared. Y squared, yes? I'm doing the round derivative. I'm doing the round derivative. I need to be up here. I'm doing the round derivative. I need to be up here. Okay, so I cover the x. 3 times 2 is 6. So that's 6x cubed y squared. 2 times 3 is minus 6xy. Right here, I cover the x. What's it? Yeah, I cover the x. Derivative of 5 is
0.
so that goes away. I cover what's the derivative of 2y? 2. And the derivative of negative 8 is 0. And so that's my answer right here. 6x cubed y squared minus 6xy.
Wait, the derivative of 8 is 2.
2. Say again?
The derivative of 8 is 2. Oh, I thought you just said the derivative of 8 is 2.
No, the derivative of 2y is 2. The derivative of 8 is 0.
Never mind.
Are you going to put the plus 0 on the end? That's better?
I was just answering.
Alright.
I thought that's what I heard you say.
Okay, anybody else? Anybody else? Anybody else? Louder, please. I didn't hear that.
But if it was 5y, then you could make it 5.
Yes.
Since it's 5x's.
Okay, so along with these derivatives right here, these are the first order derivatives, the first derivative, correct? We have what we call the second order derivative. And the second order derivative is simply the second derivative, right? It's just that it can get a little bit fancy and dicey because you can take a whole bunch of second derivatives. Right? Or yes or no, maybe so. So let's use the same example we have right here. And let's see what we mean by the second order derivative. So the second order derivative. You okay? Your second order derivative simply means take the derivative twice. So f of xx, which is kind of like the TV channel. X is into the movies or whatever it is, I don't know. Right? This means take the derivative with respect to x twice. I heard that. So over here, this is the first derivative. I just take the derivative of this with respect to x. So the derivative with respect to x of this thing right here is cover the y. So that is 12x y cubed. Cover the y, what's the derivative of negative 3? 0, so that's minus 0, so the derivative of 5? 0, and so therefore that's just 12x y cubed. Yeah, whenever you take a derivative, you're dropping a variable, you're dropping one of the variables, so you always get small over time. Yes? So what I want you to do is find the remaining second order, probably second order one. So I want you to find f of yy. I want you to find f of xy, and I want you to find f of yx.
Why is it so funny? Why are you laughing?
What is f of x?
We don't even
It means take the derivative of x first, and after you've taken the derivative of x, take the derivative with respect to y.
And it's all in the same equation.
Yes, same equation.
Oh, so you start from the new, so you start from the beginning, not the first derivative, you use the basic equation. Okay, I got you.
It looks funny at the beginning because there's so many of them. There's f of x, there's f of y, there's f of x, and there's f of y, x, yes? But it's nothing special about it, just gotta be patient. This means what? Take the derivative with respect to y, and then after that take the derivative with respect to y again.
Oh, okay.
This means take the derivative, you're right, take the derivative with respect to x, and after you get that answer, then take the derivative with respect to y. This means take the derivative with respect to y, and after you've done that, take the derivative with respect to x.
And you
And we
multiply.
can multiply?
No, multiply, just take the derivative.
But they're in parentheses
So
next
for
to
the
each
bottom
other.
two,
No parentheses, just take the derivative.
What we
so for the bottom two, you already a step ahead because you already have the derivative.
Yes, for the bottom two, you already, in fact, for this one too, you already step up ahead because you already have the first order derivative. It means you just gotta take the derivative one more time. You just gotta take the correct one.
So if we were in a test, we'd be going off the first one.
Yeah.
Oh.
I'm coming over there in a second. Yes. Okay, go ahead and find those second order derivatives for me, please. So, where's f of y? It is, where's f of y? Where's the f of y? Show me f of s y. No, I'm showing you f of y. This is 6x cubed y squared minus 6xy plus 0. You take the derivative of y, and that's no, you have to follow the order. It says, okay, take the function x, take the derivative with respect to y, which is what we have right there is 6, and then take the derivative with respect to y again. So that answer you get, take the derivative of that with respect to y. Yeah, that's when you take the derivative of y. Yes. And then take the derivative of y. Because it's possible. Because it's possible, we shouldn't do it.
This is second derivative.
This is the derivative of y. So if you over the derivative of x,
Of that x,
multiply
yes.
these two.
So when you take the derivative of x, that's what you get right here, right? Take the derivative of this.
You don't pay
with
for
respect to y.
It's 6x. For both. You take the derivative and then the
Then
y.
let us tell you which derivative to take, and just take it.
And that's when it's respected to the x.
Next. Next. You'll wait now? No, man, come on, man. That's this. And then take the derivative of x. Where it comes down. No, so it's gonna try to show you something that's good. You know, that's just
It's just because it makes it because you take a look at this. It's not going away from that. And then that's basically
There is no one. Let's go ahead. Okay, guys. Let's go ahead and work through these very carefully. Okay. What you must understand right here is this simply is the instructions. This says the function f, take the derivative of y. And when you're done, take the derivative of y again. Okay, all you have to do is, these are the instructions that you need to follow. Obviously, there are 4 of them, 1, 2, 3, 4, and so you have to be careful in working them out, yes? But that's all there is to it, just to be a little bit careful, be patient, work diligently and quietly and quickly, and you'll get there. So, the derivative of f with respect to y, we have the answer right here. It is this thing right here, yes? The derivative of f with respect to y. So now I have to look at this and then take the derivative with respect to y again, yes? So that means x is held constant. So right here, I cover the x right here, 2 times 6 is, and so this becomes 12 x cubed y. And then I go over here and I take the derivative and hold x constant, so that's just negative 6. So it becomes negative 6x. And then the derivative of 2 is 0. This right here is f of y. Let me pause right there. Questions? Now, I normally prefer to just go ahead and do the f of yx because I already know I'm working with this one, right? By just I'm taking the derivative now with respect to x. So I come up here right here to cover the y. 3 times 6 is 18. So this right here is 18x squared or y squared. I am taking the derivative with respect to x, so y is constant, so that's just negative 6. So I get negative 6y. And the derivative of 2 is 0. Notice that these two things right here not the same. Yes? Question?
Are you mimicking me?
No, actually, I mean, you making me scratch. That's what you're doing. You are getting me. Thinking about it now. Okay, and the last one right here, f of xy. So I find f of x, and I take the derivative with respect to y. So that means x is held constant. So this is not here. 3 times 6 is 18. And so I get 18 x squared y squared. And then this is with respect to y, so that's just a 6y minus 6y. And then the derivative of 5 is 0. So those are your 4, counting 1, 2, 3, 4 second order derivatives.
Is it just a coincidence?
No, it is not a coincidence.
They'll always be the same.
These two will always be the same. That is correct.
Wow.
F of x,
So,
f of xy will always equal f of yx.
It's always been the same.
That is true. Yes.
So why, okay, for f of x, y, why did you do x to y when you told me you do respect of x and then y?
For which one now? Did I say the wrong thing? Which one now?
F of x, y.
This one here,
Because I'm thinking you write down the f of x, x, y, you write down that answer, and then you do.
And what I'm saying is there's no need to go right back here and start again if I already have f of x.
That's what I'm saying, so why not write f of x first and then do respect to y?
That's what this means. That's what this means. That's what we did. No? We took the derivative of this with respect to y. So x is held constant. Okay? Okay, let's give you one more to try. Let's give you one more to try. And then we'll see where we stand from here. So let's see, I have f of x is equals to, let's go classic, 3x squared minus 2xy plus 4 y squared minus 2x cubed y to the 4th. Okay, I want you to find the 6 derivatives. So f of x, f of x, y, f of x, x, f of x, y, f of y, y, f of x, y, and f of y, x. There are 6 of them. f respect to x, f respect to y. That's your first order. And then you want to find f of xx, you want to find f of yy. And of course, you only need to find the one in the middle once.
Because they're the same.
Because it's the same, f of xy, f of yx.
I can't.
Because they're the same.
I mean, it looks complicated. It's not that hard. Though. You just gotta slow
Yes,
it
yes,
down.
guys, slow down and be careful and be patient. It'll come to you. Yes. This needs a variable of one function, so technically, but I'm wrong. Yeah, thank you for pointing that out. This should be a
Oh yeah, the x and y.
double ordered function.
Because then that okay.
Okay. Let me give you a few moments. Let me give you a few moments to finish that off. To polish that off. When you finish, check your answers with the person next to you. See if they're right. And if one of you is wrong, let me know. So I can come by and tell you who's right, who's wrong. I didn't finish. I actually, I think I left half of them on my office. So the half that I had, I graded, and the other half I had.
Is it grade for blackboard? I mean, not blackboard, math.
Yes.
No, because I think it's so funny when people like to
Come on, Mr. Middleton. Break. Come on. You the word.
No, no.
Professor, I have a quick question.
We got to find all four of those?
All 5 of them.
So would you include x on this for y to the second?
Yes, because you cancel over. Cover this right here. What's in the real form? 0. So 0 times this is.
So I don't bring up.
Yeah, you can, but put it in front of 0. What does that do for you? Still 0, right?
But if it was finding the y, then I would have to find it.
It would be 8.
Like the one that circled. That's the one.
Oh, yeah.
What you do right here? So you're just like, why are you covering the X? Okay, this is the first one. The next one is with respect to what? Oh, hold on, yeah, so wait. Cover all the X. You finish. the concentrate of the water bring it down.
I don't know.
You doing anything correct so far? Sure, got an ugly start.
Mine only got me like 7 or something, because I haven't had one intervention at all.
Cover the wire, right?
And I was like, can I get a care package for somebody? I've never hit a bag, but like, I needed it.
Can you check me?
Okay, that means y'all finishing, so let me go ahead and put this on the board. And then, huh? I didn't check it again. I got disturbed by this one. Yeah, that looks right. Somebody got that answer, so it looks right. Okay, gang viewers. Okay, gang viewers, let's go ahead and work through these, shall we?
Are you saying kind?
Yes, kind. Y'all not kind?
He's not.
Oh my goodness. Why you gotta throw one of the bus like that? That's not kind. So I have 2 unkind people in here. Look at that. Look at it. Okay, so the first derivative with respect to x, f of x, xy is.
Can you go on that side of the board, please?
Second.
Just go down the other side.
Yeah, can you go on that side?
So f of x, xy right here is the derivative of this is 6x squared x. Ooh. Remember, what we're doing is we're covering the y, we're taking the derivative and then bringing the answer down, right? So I cover the y right here. The derivative of 2x is just, and I bring down the y. The derivative of 4, cover the y. What's the derivative of 4? Derivative of 4 is 0, and so this becomes 0. And then the derivative of this right here will be minus 6x squared, and then I bring down the y to the 4th.
Oh, how you get 0 again?
I cover up the y. What's the derivative of 4? 0.
You have to break the 0.
No, I'm about to erase it.
Oh.
But
It's good to know.
no, just good to have in your notes.
Yeah, let's have zeros.
Hmm?
It makes it more clear.
Okay, so I find f of y.
F of S. Why didn't you do F of X X?
You want to do f of x first?
No, do that. It
Yeah,
makes it easier.
why?
when
Why?
It doesn't matter. I'll get to all of them. So f of y, this is 0. That's minus 2x. Then this is plus 8 y, and then that's minus 8 x cubed y cubed. Questions? Now I take the derivative of this, but with respect to x again, so f of x means I'm looking at this as the starting point. So that is 6, this is 0, and then the last one is 12xy to the 4th. Derivative. Questions?
I get that again.
I mean, I would
Go back over. So right here, the derivative of 6x is just 6.
Okay.
The derivative of 2 is,
0.
and then the 0 cancels out the y.
Okay.
Then the derivative of 6x is 12,
12.
and then bring down the y to the 4th.
Okay.
Is it okay if I just have 2 zeros? I mean, just keep bringing it. It just helps me out.
That's fine. I understand what 0 means. That's fine. Yeah.
Do we have to put 0?
No. I'm just helping you out. No. Okay, f of y. And that's x comma y. And so this is the starting point, right? I don't need the 0. The derivative of 2 is 0. So this first thing is 0. The derivative of 8y is 8. And 3 times 8 is minus 24x cubed y squared. We getting a little bit better? You getting a little bit better?
Yeah.
A little bit? A little bit? Un poquito. Okay, last one. Which one you want? F of x, y, f of y, x?
X, Y.
F of x, y. We're not doing the other one because we know once we have this, we have the other one. So we need to do one of them. So, derivative with respect to y. That's a 0. That's a minus 2. And y times 6 is 24. X squared y cubed. So therefore, f of yx will also be minus 2 minus 24 x squared y cubed.
Well, that's kind of how you can check your answer, so if they're both the same, you know you're right.
Yes, that's a simple way to check your answer.
And so when we go any farther, will we go like f of y, y, y?
You can, but we won't.
Okay.
Yeah, there are 4 second order, the third order, there are actually 8 of them. And yes,
Where did you find the F of Y?
f of y, I didn't work it out. I just know that these two are the same.
I mean, yeah, but I'm saying like.
Okay, so this is f of y right here. What's the derivative of 2x?
Okay.
0. The derivative of 8y is, the derivative of 2x is 2. Alright, you raise the minus sign, that's what it is.
Oh, yeah.
And then the derivative of 8y is 0, because it's respect to x. And the derivative of this, 3 times 8 is 24. And that gives me my answer. Anybody else? Anybody else? Okay, so what has happened is that I have sent out an email for test number 4. It will be like test number 2. Part of the test is take home. This part of the test is take home. So I have emailed you the assignment, and it's due on test day.
What's testing?
I believe it's the Tuesday after Thanksgiving.
Oh, good.
Let me comment. Okay, and so I have emailed that to you right here. As usual, you can ask me any questions. You can text me at any time. It's on the internet machine. My number's on there, and then you can.
Study guide.
Study guide? Yes, I'll post one.
Today?
No. Well, okay, I shouldn't say no like that. I should say no as in I'm not sure how far I'll get. So depending on how far we get, what's
We
going to
only
be.
have
on.
no time to have office hours.
Yeah. Yeah. Just not tomorrow because tomorrow's a holiday.
It's just, it's not that bad.
Yes.
Like, I can't do it over the weekend because I'll be out of town.
Okay. This is just 2 months before.